So the main goal of today, when we end, is that we want to have all of the tools necessary to solve and to describe the complete solution set of an arbitrary system of linear equations, however many variables it has and however many equations bind to those variables. And so that's kind of the E3 goal. It's the capstone of our first chapter of linear algebra. And we've gotten our first taste of it already as the last activity that we did from the first section 1.1. So here's what that activity looked like. They gave us a linear system that had two equations in it and which had four variables, x1, x2, x3, and x4. And the task on this problem was to figure out a way to describe the solution set, so all the solutions of this linear system of equations, by observing that if we take x2 and x4 and we rename them into meaningless parameters a and b, then we can solve for x1 and x3 in terms of a and b, which this team has done, right? And thereby come up with a description of the entire solution set. You might ask yourself, why did the people who wrote this question choose the variables x1 and x3 to be the meaningless parameters? Could we have made a different choice? Does it matter which choice we make? Are we forced into that choice in some way? And that is going to be something that we find out along the way today. Just to give you the preview, those variables which can be picked to be meaningless parameters, those are the variables which, once we know their values, we will be able to determine uniquely the values of every other variable. Those meaningless parameter variables we're going to call today free variables of our system. And those variables which are not free, those variables which must be defined in terms of those meaningless parameters, those are going to be called bound variables. And we call them those names because free variables, because we can pick any real number that we want to for a and b, we have a free choice for what to pick for A and what to pick for B. But as soon as we make those free choices, we don't have a free choice for the values of the other variables because they are determined, according to these equations, per team 2, by the values of the parameters that we chose. If I put these expressions for x1 and x3, if I stuff them into this vector, that's going to give us a way of rewriting this solution set in a convenient way that is going to help us to be able to describe similar solution sets down the line. So I'm just going to take the liberty of starting up an equation editor here. By the way, Google Docs has a pretty terrible, basic equation editor. It doesn't do a whole lot of things very well. So there is a free add-on called Hypatia that I like to use when I'm working in Google Docs and writing mathematics. There's instructions on our Discord site if you're interested in adding it to your Google ecosystem. It only takes a couple of clicks. So what we would then be doing here is putting in my solution set. So I'm using these curly braces because I'm describing a set. And in my set builder notation, I'm going to write on the left-hand side, let's see, so I want an array here, and I want 4 rows and 1 column to describe my vector here, insert. And the entries are going to be question mark A, question mark B. But of course, we want to replace those question marks with the expressions that this team discovered for x1 and for x3. So 3 plus b minus 2a. I'm actually going to write it so that the a term comes first. So 3 minus 2a plus b. And then the x3 will replace with negative 2 minus 4b. And once I've done that, and then I've quantified a and b, so I'll put a little vertical bar here to say that the values that we want are the a's and b's such that a and b can be any real number. Okay. There we go. I'll click Insert, and it should drop that into our document here. It's weird that it puts like extra notation inside of the vector. That doesn't look so great. Anyway, I don't know how to fix that right now, but it's not important. So there is a sort of a complete expression for which vectors of 4 quantities, x1, x2, x3, and x4, are a part of the solution set of this linear system. But what's nice about it is that all of the entries in that vector are a combination of either constants, like this 3 and this -2, multiples of a, like -2a and this a, and multiples of b, b, -4b, and b. And so what that allows us to do is it actually lets us factor out those parameters, a and b, and to rewrite this solution set in a slightly different way. And so if I rewrite that in a different way, what that might look like is, let's take all of the constants, those things that aren't coefficients of a or b, and let's package them in their own vector out here in the front. So again, 4 rows and 1 column. Again, I don't know why it's putting extra boxes around everything, but that's something I'll fix later. So the constants, the first entry has a constant of 3. The second one doesn't have a constant, so I'll put a 0. And then there's a -2, and then there's no constant in the last one. And then after that, we have some coefficients of a, right? We have some terms that have a as one of their factors. And so if I put that, if I factor out that a, then the coefficients of a that I factor out are going to be -2 in the first term, 1 in the second component, but then the third and fourth components don't have any a's in them. So the vector that would be multiplied by a here is -2, 1, 0, 0. And then the same process applied to b. By 1, and I read off the coefficients of b, which in the first component is 1, in the second component is 0 because there's no b's, and then the third and fourth components are -4 and +1. So when I rewrite it this way, what it does is it kind of gets us back into the same kind of position we were in when we were thinking about describing a system of linear equations as being made up of a combination of vectors, right? So what we're saying here kind of, right, is that every solution of this system of two linear equations is some multiple of this vector added to some multiple of that vector added to this constant vector, 3, 0, -2, 0. Right? So any a and b that I choose, if I form this combination of vectors, it's going to give me a solution of this system. And every solution of this system can be obtained in that way. Right? So that's our ultimate end goal for today, is to figure out how to, now that we know what the last step in the process looks like, right? In this system, we didn't have to do any grunt work before we just did this process of assigning meaningless parameters to a couple of the variables and then solving for the other ones in terms of those parameters and then unraveling our solution as we did down here. And so that's the last step in the process. Now our job is going to be to figure out what are the first steps in the process. How can I get an arbitrary linear system of equations, boil it down into a form in which we can do this? How do I make that choice of which variables we can assign free parameters to and which variables must be bound by the values of those free parameters? And then once we've made those assignments, then this is what the end of the process looks like. So this is probably an activity that I'm going to return to over and over again throughout the semester until it gets sort of drilled into our heads, right? That this is what the end of the solution set process looks like.